Hi everyone, welcome back to chemistry class. In our last class, we have learned that one mole of any substance contains 6.022 into 10 to the power 23 atoms, ions or molecules. Now this number 6.022 into 10 to the power 23 is called as the Avogadro's number or Avogadro's constant. So Avogadro's number can be defined as the number of atoms, ions or molecules that are contained in one mole of any substance. Now moving on to the next topic, we have empirical and molecular formulas. Empirical formula, it is the formula which represents the simplest whole number of atoms of various elements present in a molecule of a compound. Whereas molecular formula, it is the formula that represents the actual number of atoms of all elements present in a molecule of the compound. So if we have benzene contains 6 carbon atoms and 6 hydrogen atoms. Therefore, the molecular formula of benzene is written as C6H6. Now, if we take the simplest whole number ratio of the number of atoms for these two elements, carbon and hydrogen, we get 1:1. Therefore, the empirical formula for benzene will be CH. Likewise, if we have another compound, C2H6, this is ethane. Ethane has 2 carbon atoms and 6 hydrogen atoms. So the molecular formula is C2H6. Now if we take the simplest whole number ratio for this number of carbon and hydrogen atoms, we get 1:3. Therefore, the empirical formula for this ethane molecule will be CH3. So once again, empirical formula represents the simplest whole number of atoms of various elements present in a molecule of a compound, whereas the molecular formula represents the actual number of atoms of each element present in the compound. Now, in the last class, we have also calculated percentage composition of different compounds. Percentage composition, as we have seen, is just the mass percentage of the different elements present in one molecule of the compound. So if we know this percentage composition of the compound, we can derive its empirical formula. And if we know the molecular mass of the compound also, then we can derive the molecular formula also. Let us see how this is done. Suppose a compound contains 75% carbon and 25% hydrogen. And its molecular mass is 16 atomic mass units. What will be its empirical formula and what will be its molecular formula? Let us try to derive this. To make things easier, let us draw a table. In the first column, we write down the elements. Now in this compound, we have 2 elements, carbon and hydrogen. So we write this 2 here. Then in the next column, we write down the percentage composition. Percentage of carbon in the compound is 75% and percentage of hydrogen is 25%. Then in the third column, we write down the atomic mass. Atomic mass of carbon is 12 and mass of hydrogen. The actual mass is 1.008, but to make our calculations easier here, I'm taking 1 for the mass of hydrogen. In the fourth column, we calculate the atomic ratio. This atomic ratio is obtained by dividing this mass percentage by the atomic mass. So in the case of carbon, it will be 75 divided by 12. This will give 6.25. And for hydrogen, 25 divided by 1 will give us 25. Then in the next column, we find out the simplest atomic ratio. To find the simplest atomic ratio, we divide these atomic ratios by the smallest one among them. Now we have only 2 here, and the smaller one is 6.25. So we divide both of these by 6.25. If we divide this 6.25 by 6.25, we will get 1. And if we divide 25 by 6.25, we will get 4. Now from here, we see that the simplest ratio of number of atoms of carbon in hydrogen in this compound is 1:4. Therefore, the empirical formula will be C1H4, which we simply write as CH4. So from the percentage composition, we have now derived the empirical formula. Molecular mass of the substance is also given. The molecular mass is 16 atomic mass units. So after finding the empirical formula, we find the empirical formula mass. To find the empirical formula mass, we just add up the atomic masses in the formula. So carbon 12, mass of hydrogen is 1 into 4, 4. So empirical formula mass is 16. Then we find the factor N. N is given by molecular mass divided by the empirical formula mass. Now we are given that the molecular mass is 16 atomic mass units. So this 16 is divided by the empirical formula mass, which is also 16. So N in this case is equal to 1. The molecular formula is equal to N times of the empirical formula. So molecular formula will be equal to N times of empirical formula, which is CH4. N is 1 in this case. The empirical formula is CH4. CH4 multiplied by 1 will give us CH4. So in this compound, the empirical formula and the molecular formulas are the same. In other compounds, they may be different. But in this case, the empirical formula and the molecular formulas, they are the same. Now, our next topic is on limiting reagents. Now, in many chemical reactions, it happens that the amount of one of the reactants is very much less or lesser than the amount that is required by the balanced chemical equation. In such cases, the one which is present in smaller amounts will get used up first. And once the reactant gets used up, no more reaction takes place and no products are formed. So in a chemical reaction, The reactant which gets used up first and limits the amount of product formed is called as the limiting reagent. For example, hydrogen and oxygen, they combine to form water. Now, according to the balanced chemical equation, 2 moles of hydrogen will combine with 1 mole of oxygen to form 2 moles of water. So 2 moles of hydrogen require 1 mole of oxygen. If we have 2 moles of hydrogen reacting with 2 moles of oxygen, 2 moles of hydrogen require only 1 mole of oxygen. So if we have 2 moles of oxygen, that means hydrogen will get used up first. And therefore, in this case, hydrogen will be the limiting reagent. Let us try to understand this with another example. If 50 grams of nitrogen reacts with 10 grams of hydrogen to form ammonia, which will be the limiting reagent in this reaction? Now, in this given reaction, the mass of nitrogen is 50 grams. So number of moles of nitrogen will be equal to the mass divided by molecular mass. Mass of nitrogen is 50 grams in this reaction. This we divided by the molecular mass of nitrogen, which is 28. So how much do we get here? 50 divided by 28 will give us 1.76. Then number of moles of hydrogen will be mass again divided by molecular mass. Mass of hydrogen is 10. The molecular mass of hydrogen is 2. So 10 divided by 2 will give us 5. Remember that once again, I'm using 1 for the mass of 1 hydrogen atom. So for 1 molecule of hydrogen, the mass will be 2. So in our given reaction, we have number of moles of nitrogen, which is 1.76, and number of moles of hydrogen, which is 5 moles. According to the balanced chemical equation, 1 mole of nitrogen should react with 3 moles of hydrogen to give 2 moles of ammonia. 1 mole of nitrogen reacts with 3 moles of hydrogen. Therefore, since we have 1.76 moles of nitrogen in our given reaction, 1.76 moles of nitrogen will react with 3 into 1.76 moles of hydrogen. So 3 into 1.76 should give us 5.28. Now see here, 1 mole, according to this balanced chemical equation, 1 mole of nitrogen requires 3 mole of hydrogen. Since we have this much moles of nitrogen in the reaction, this 1.76 mole of nitrogen will react with this 5.28 mole of hydrogen. However, in our given reaction, we have only 5 moles, not 5.28 moles of hydrogen. That means in this given reaction, hydrogen will be used up first. Therefore, hydrogen will be the limiting reagent in this reaction. Now, the relative amounts of reactants in products in different chemical reactions are shown by their balanced chemical equations. And these balanced chemical equations can be used to find out the mass to mass relationship, mass to volume relationship, or mass to volume relationship of different reactions. And these calculations based on the balanced chemical equations are called as stoichiometric calculations. Let us see one example here. How many grams of oxygen will be produced by the complete combustion of 8 gram of methane? How many grams of oxygen will be produced by the complete combustion of 8 gram of methane? Now, to find this, first we need to write down the balanced chemical equation. The balanced chemical equation for combustion of methane will be CH4 reacting with oxygen to give carbon dioxide and water. Remember, when hydrocarbons are burned in air, they produce carbon dioxide and hydrogen. Now, you need to know how to write the balanced equation for these combustion reactions also. Here we have methane. In methane, one carbon atom is present. So, number of moles of carbon dioxide formed will be 1. And here we have 4 hydrogen atoms. So, number of atoms of hydrogen also in the product should be 4. So 2 molecules of water will be formed. So methane burns in air, undergoes combustion to give carbon dioxide and water. Now, is this balanced? Let us check. Carbon we have 1H, hydrogen we have 4H, oxygen in this case on the right side we have 4 atoms, so this will be multiplied by 2. So 1 mole of methane combines with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Now, molecular mass of methane will be 12 plus 4, that is 16. And carbon dioxide 12 plus oxygen 16 into 2, 32. So this will give us 44. Water, molecular mass of water is 18. There are 2 molecules, so multiply by 2, we get 36. From here we understand that 16 gram of methane will give us 36 gram of water. So if we have 8 gram of methane, how many grams of water will be formed? Let us make a change here. This should be grams of water, because methane on combustion will give us carbon dioxide in water, not oxygen. So how many grams of water will be produced by complete combustion of 8 gram of methane? 16 gram of methane gives us 36 gram of water. So 8 gram of methane should give us 8 into 36 divided by 16. So we will get 18 gram of water. So that is all the time we have for today. Let's continue in the next class.